All right, so this is going to be kind of a laid back, but we do have slides, so it'll be not quite my normal sort of fast-paced, well-rehearsed talk that we see at ONS and stuff, but interject at any time, conversation's okay, we can take breaks, but we'll be using a slide deck. So this talk is going to be kind of a, where are we with integration packaging, some interjections about what we want to do in the future, and then I would love to, we have almost no one here, but if anyone has any ideas about the requirements that they want from us and other ways that we can improve our stack, that would be cool too. So a quick outline about what we're going to be talking about today. I like to think of basically what we serve in terms of a 3-layer stack. I think the abstractions are useful in that way. So I'll be describing them in that order. The first layer is the packaging layer, so that includes things like RPMs and debs. The second layer is a configuration management layer that consumes the packaging layer and then does additional configuration on top of that. So this would be like our Puppet module and our Ansible role. And then the third layer, top layer, is the pre-configured images layer. So those consume both the packages and the config management thing to create a sort of final, well-configured artifact that comes out the other end of the pipeline, like a Vagrant base box or a Docker container in the opposite order. And all of those are built with a tool called Packer, which we'll talk very briefly about. So cool, jumping into the packaging layer, again, I think of this as handling system level dependencies. So for OpenDaylight's case, that would be mostly installing Java and then laying down the basic files in the file system. So just dropping things, our tarballs extracted artifacts in the right place, making sure they have the right permissions and such. Creating the users and groups to set the right permissions, of course. We also do configuration of systemd in our case, but in general, the thing that's going to manage OpenDaylight service via the packages. We currently support an RPM, or series of RPMs, which we'll talk about in a second. We have an intern. I have hired an intern through the Linux Foundation to start working on debs. Super exciting. I have tons of reasons why I'm excited about that. We'll come back to it. Anyway, but they'll start in May, I think, so it's going to be a few months more before, unfortunately, that work starts going on. They're already getting spun up, we're already communicating emails and things, so I'm pretty excited. Very talented intern, too. I think it's going to go well. All right, so the RPM, it's available under the integration packaging repository. Every screenshot here is old, by the way. This is sort of a deck that I forked and then changed and stuff, but I didn't update any of the screenshots because I didn't think you'd really care. But all the screenshots are like 6 months old. It's built and hosted on the CentOS community build system, so that's fairly official, I think, and robust and doesn't seem to break, and it has nice tool chains, and I've finally worked with the committers to get sort of the right build tags, and so we're all being consumed correctly. This is the web interface for the Koji CBS instance. Let's see a quick example of how to install from the RPM. This is the trend. I'll show how to install with each of these tools as kind of a teaching thing about them. So with RPMs, you have a repo configuration file that basically describes how to find our repository. So a .repo file. It just contains, the most important thing is the URL there that says, here's how you find the community build system, here's how you find OpenDaylight's RPM. There's an example of that .repo file. That's actually what this screenshot is of that we provide via integration packaging. You can curl down that example, and there are a bunch of other examples. This one's for lithium. There's current ones for beryllium. And then once you have that file in the right place, it happens to land with the right permissions, which is quite nice. You can just sudo yum install -y OpenDaylight and downloads, and you're good. You can then start OpenDaylight systemd service with sudo system control start OpenDaylight and verify that it's running with is active, and it in fact is. So that's all fun. We can grab our shell and install any features that we want. So that's the end of the RPM example. A few quick to-dos. RPM-wise, we have started signing ODL's artifacts, or tarball release artifacts. We also need to start signing our RPMs. We've got a decent web of trust going on here, so I think it's time. We are not doing anything right now in CI for integration packaging, and that's going to be a trend across the whole stack. We need to start, if we could build RPMs in CI, that'd be great. If we could test RPMs in CI, that'd be great. We're currently able to test both the RPM and the package, the configuration management layer via Puppet, via OPNFV, because that's how they consume OpenDaylight. And so they're doing that every single day with their CI builds and running big complicated tests and such against it. So we have a lot of confidence that that part of the stack works at least. I talked about building the RPM in CI, or not really CI, but in OpenDaylight's infrastructure. It's also time now to start directing users at the packages. In our downloads page, we've only linked to tarballs for a long time. We had a conversation about doing it for Beryllium, but it didn't happen. Maybe not the best reasoning about why, because they're not hosted on Nexus, which was the reasoning, and so it's not like an official artifact in some ways, but I think the community build system is a good official place to host it. So just more discussion would need to happen, and then for Boron at least, I think we'll start directing users there more publicly. That's it for RPMs, and I could talk about debs, I guess, but if anyone has questions about debs, we could talk about that later. Yes? Can you, first off, because it's mostly about the recording, but can you say that into the mic?
So my question is, so do we also have the source code RPM too?
The source to create the RPM?
Yeah.
Yeah, so, exactly. Are you talking about the the availability of the built SRPM or the source that created the RPMs? The second option? Yeah, yeah. So everything that since this is an informal thing, I'll just actually show you. Everything is available via the integration packaging projects repository. So this is our mirror on GitHub of the repository, which is a little easier to view. But this is the RPM build logic. And so there's this build.py script, for example, that's kind of hosting everything. And then there's other logic that it breaks out into. So creating spec files, for example, like here's a bunch of, these are all automatically generated spec files from this template. But yeah, everything's available. The build logic is all in version control. The specs are there to see. They're automatically generated, so we don't really need to keep copies of them there, but we do so people can more easily kind of see what's going on. But yes, everything's publicly available. Everything's automated, very well automated, actually. So that's, yes, short answer, yes. Cool, so config management layer. Again, I think of the config management layer as consuming the package layer and then doing any additional configuration that we need after that. It can do things like edit files to change carafe features that we may install or port mappings. It could open ports through Firewall D or similar. It can manage Open Daylight System D service, so starting, stopping, restarting. First example of a configuration management tool temporally that we created is Puppet, is a Puppet module. It's available on GitHub. It's technically under my account right now. We wanted to put it under the Open Daylight Forge, but that has not existed for years and still doesn't exist. But it is submoduled under the integration packagings repository, and so you can find it that way. We'll move it to Puppet Forge once we can. Or wait, I keep saying Puppet Forge. I meant Open Daylight Forge, ODL Forge. It's also available on Puppet Forge to consume, and users can find it that way, and it has a nice pretty web UI for downloading and things. One of the advantages of the Puppet module is that it's fairly stable, and so we've had it around for a while. Our API is developed. It's been consumed by OpenFE for a long time, so the feature requests and stuff that have come in have been served repeatedly, iterations and iterations, and we're fairly happy with where it's at now. It's also very well documented, so let's take a quick scroll through kind of old docs, but there's everything about like setting it up and vagrants environments for playing with it, and API reference docs for all the different params you can play with and things. We've had a fair number of contributions to the Puppet module, and I think part of that is because we've got pretty good contributing docs and stuff, and so if you care, you can go look at how to communicate, or how to raise issues, or how to send patches, or different types of syntax and style tests, and system tests, and testing continuous integration, and beaker tests, and all this stuff. We also have the best OS support of any of the options we're going to talk about today with the Puppet module, so we can deploy, and when I say support, like we could deploy against other operating systems, and these numbers need to be increased, again, old screenshots. But when we sort of support one, we're running a full set of beaker tests, which we'll talk about in a second against it, and so we're quite sure that it works. It's not just sort of an arbitrary tag of we supported, we tested it once or something. The community actually brought Ubuntu support. Again, it's being consumed by OpenFE, and there are installer projects in OpenFE that are based on Ubuntu, and they needed to use it as well, and we didn't have, we still don't have dev packages. So we had to create, we had to create a tarball-based install method. So the idea here is that instead of consuming the package layer, we just skip the package layer, consume tarball autofix directly, lay those down on the file system. Puts a lot more logic in Puppet's hands, and I don't really like that because it's just not, it's inelegant and it's fragile, and not a big fan of that whole install path, which is one reason why I'm very excited about moving to debs, so we can just install the right type of package for the operating system and not have to have so much logic in the Puppet module. You can pass in this also allows you to build custom, why I have the slide is because if you're kind of I don't know, if you're doing some product based on Open Daylight or something and you have a custom tarball that you haven't packaged up, you could just use this URL parameter to install it with this Puppet module as well, and everything else should play well. Yeah, I talked about this. We're going to be moving to dev packages as soon as possible, and that's going to be wonderful. The Puppet module is super well tested, so we've got this first type of testing called there's two types of testing in Puppet world. The first type is called RSpec Puppet. It's not really that cool of a testing framework, so we're not going to talk about it that much, but we have really good test coverage for it, and it runs frequently, and so it catches sort of stupid small checks, and that's not bad. It runs in CI via Travis, so that's all fun. The really interesting testing work, though, that I do like a lot about Puppet is via a tool called Beaker. Beaker deploys against real VMs, or actually containers now, which is super exciting. We've moved away from using VMs. Now we can use containers, and they're so much faster to work with. And then it verifies the resulting state. So it does an actual install against a real thing, and then checks aspects of the system to assert that they're correct. It repeats that for various parameter configurations into the Puppet module. At a high level, so when I say at a high level in this presentation, I'm going to show you way more information than you can take in, and I really just want you to see like the structure of the information or how much there is, colors sometimes, so don't be too overwhelmed. At a high level, Beaker tests look like this, where there's just lots of different checks being run, and yes, this user is installed, and yes, all these tests pass and stuff. I think we're at, it doesn't matter, but like 130 tests or so at this point. So what happens in detail, and I'll break out the parts that I want to show you and highlight them, and we'll talk about them, is that we start with in this case, CentOS 7 virtual machine. Now we actually, again, use containers. And we install Puppet on it. We then repeatedly Puppet apply, which is how you sort of do Puppet stuff, a test manifest with different parameter combinations. We then go verify things about the system. So we're, in this case, checking that Open Daylight systemd service is running. In this case, we're checking that certain users and groups are installed. In this case, we're checking the contents of a particularly important file to verify that certain features will be set to install at boot. At the time, there were 51 examples, and they all passed. So I like Beaker a lot, big fan of it. It gives me a lot of confidence as the module maintainer that when we accept a pull request or add some new feature, we're not about to break all of OP and FE, which is a total possibility. And very scary sometimes. Yeah, so let's see an example of using the Puppet module. This is a really cool project for the people who we should do like introductions since there's so few of us. Should have done that to start with, maybe afterwards or something. Anyway, so there's a really nice sandbox that I've created I call it Vagrant Open Daylight, that you can think of as a matrix of deployment options to operating systems. And so you can do just pure RPM installs against a bunch of different operating system choices, or pure or Puppet-based RPM installs, or Puppet RPM installs, or Puppet Tarball installs, or Ansible installs against the same set of operating systems. And so it's a great way to play around with different deployment options. So we're going to use this throughout the presentation as a place to source examples. So at a high level, again, I'm going to overwhelm you with stuff. This is what a Vagrant definition looks like. If you're not familiar with Vagrant, it's mostly documentation, so it's fairly short for defining a complete virtual machine and the installation of Open Daylight and stuff. In detail, this is really the only important line. It's pointing at a manifest, which is a Puppet file that describes what you want Puppet to do. It, in particular, is pointing at this manifest that's saying, apply the Puppet class Open Daylight, passing the parameter extra features with this list of one extra feature, just so we can have some sort of example to reference. We can then provision the box with the Vagrant up name of box. We'll see in the output that our Open Daylight RPM was installed, that we did certain configuration things, and so in this particular thing, this particular line has to do with the configuration of the craft features file because we passed that particular parameter. So let's go ahead and grab a shell in the box and poke around a bit. So this is Vagrant SSH, name of box, and now we have a shell on our new virtual machine. We can verify that Open Daylight systemd service is running, as we did before, with system control is active, and it is, which is exciting. We can then go ahead and grab a shell on this Open Daylight instance and do any feature installs that we want or whatever. Actually, in this case, we're grepping against feature list to verify, or config list to verify that our configuration was read in properly, and it was. We can grep against feature list to check that the configuration worked, I guess. I mean, this is checking the same thing, basically, and the feature was installed. into that example. In the future for the Puppet mod, we're going to have an official Open Daylight Forge account. Steven was pointing out to me recently that my Gravatar image it has to be the Open Daylight image, because if it wasn't, then our Forge accounts would have like my picture on them, and that would look really awkward. So we need to separate those things more elegantly. I just haven't had the cycles to do that. Excuse me. We're also, again, going to be moving things into CI. This is going to be a big theme of the Boron release. We actually are going to have this probably today. Tim sent a pull request during the last talk, during Ed's talk, submitted a pull request to add cluster support to the Puppet module. So that's super exciting. We need to be able to configure the user pass of Open Daylight, but it's actually really awkward to do. You have to either manually manipulate a database or start Open Daylight service and use a REST call and then restart Open Daylight, and that is not a comfortable thing for Puppet to do. It's just not, Puppet's not good at that. So I've been staring at this feature request for a long time, trying to figure out how we're going to implement that, but we have to have that for RDO Manager and various other deployments, and so somehow we'll figure that out. Moving on to the Ansible role, I'll back up for a second. The Ansible role came second, since we're talking about it second. I do prefer it, though, over the Puppet module, just to be real blunt about it, because I think it is drastically easier to work with. You can get a lot more done as far as adding features per unit time. I think it's a lot easier to debug, and I'm a big fan of YAML. And so you're basically writing everything in YAML instead of Puppet, which is based on Ruby, and then really it's not so much Ruby as a ton of domain-specific languages on top of Ruby, and so you hardly even know where your DSL is getting read, and it's very strange to write things for. So I prefer Ansible. It's the same deal. It's available on GitHub, and then it's submoduled from the integration packaging repository, so you can find it that way. Similar to the Puppet Forge, there's this thing called Ansible Galaxy that has a nice, pretty UI for consuming it and finding it and such. The big advantage, as I hinted at with the Ansible role, is that it's quite simple. And so this is a bit out of date, but this is the core logic of the Ansible role in this main.yaml file. And you can see it's like 5 or 6 lines of YAML, super simple. Those lines do break out into slightly larger things, but the things are not very large. This is a very standard one responsible for starting Open Daylight System D service. This is the most complicated one in that list, and as you can see, it's not particularly complicated. It's doing a lot of logic. It's using a template to manipulate a file's contents, to install certain craft features at boot, and then it's using handlers, notifying handlers to do a clean restart of Open Daylight. So it's a lot of logic for a few lines of YAML. In total, there's 191 lines of YAML at this time in the Ansible role, so overall, not a huge amount of things to parse. You can probably take 10 minutes and read through it and understand everything going on. One reason why it's so short, though, is because Ansible actively rejects Puppet style of testing. So these are quotes from the documentation: "Don't unit test your playbook," pretty explicit. Ansible believes you should not need another framework to validate basic things of your infrastructure. They're definitely poking at Puppet with these. And they have kind of an alternative. So backing up, there's no RSpec Puppet or Beaker, so that's a little sad. I liked Beaker, but not too sad about RSpec Puppet. This is the alternative. They are all about failing fast and cleanly, right? So as devs, it's super nice when we don't have a bunch of other logic going on, and it's difficult to tell where it fails, and it just keeps dragging on and like dying slowly. That's what you see with Puppet, right? With Ansible, since anything goes wrong, it's very obvious what went wrong, and it just stops the process, and you can go back and fix it. You can also do testing, as we'll talk about in a second, on not related to Ansible testing, but sort of Open Daylight testing. You could install Open Daylight and then run our integration test against it and verify that it works in that way, and that would be very good testing. Ansible's rejection of unit test allows you to focus on deployment logic. We'll see another parallel example to the one we did with Puppet. This is, again, using the Vagrant Open Daylight project. At a high level, this is the box definition. Again, mostly docs and even shorter than before. The only important line is this one, which is pointing at rough equivalent to the Puppet manifest we saw before. This is called an Ansible playbook, but the same idea where we're saying apply the Open Daylight role to all hosts as root, except all the defaults. So we can go and provision the box with vagrant up name of box until 7 Ansible in this case. At a high level, it looks like this. And so I really want you to look at the colors in this particular picture. Let me full screen that so it's, I think, totally visible. Yeah, there you go. So this is the type of output that you get from Ansible. And the yellow stuff are things that changed. The green things didn't change. The blue things were skipped because of the state of the system. So a lot of things changed in this picture is what I want you to notice. In detail, we do things like add OpenDaylight's yum repo, so that's curling down that file I talked about, .repo file I talked about, and then installing ODL via its RPM. We can do things like check whether firewall D is active and open ports if it is. It wasn't, so we didn't open any ports. And then start ODL system D service. Let's go ahead and grab a shell in the box and poke around. Again, Vagrant SSH name of box to do so. We can verify sanity check that OpenDaylight system D service is running in the same way. We'll do another example here. So this case, we're in this playbook, we've added a parameter at the bottom there, extra features, and we're using the same test feature that overriding the default of nothing with this one test feature. And we'll go ahead and re-provision the box with Vagrant provision name of box. At a high level, this is the output that we get. Notice that there's a lot of green. So there's only this one yellow task where we configured OpenDaylight's craft features, and there's these 3 handlers that were called to do a clean restart of OpenDaylight. By the way, you don't need to do a restart of OpenDaylight to add craft features, but you do need to remove craft features. And I can't tell whether you're adding or removing, and so we always do a clean restart. Excuse me. Yeah, so this is the output that we just talked about. Let's go ahead and grab a shell in the box and poke around a bit. Again, OpenDaylight's still running. It hasn't crashed and died on us. If we grab a craft shell and grep against the config, then our test feature was read incorrectly and it was installed correctly. If we grep against the features that are actually installed, the X means it's installed, by the way, in case you don't know that. I like to do a remote host example here, but we didn't. I'm not going to do it. So anyway, you can apply against remote hosts, really cool as well. In the future, we're going to have cluster support for Ansible. Now that we have it for Puppet, it should be, once you have a feature for one, it's really easy to add it to the other. So we'll have this pull request that works for Puppet. It'll be, soon it should follow to Ansible. We need an official Ansible Galaxy account, like I hinted at, so my picture doesn't randomly show up in strange places. And I can change my Gravatar image, that'd be nice. This config user pass thing still exists. Once we have it in Puppet or Ansible, we can move it to the other. Cool, so moving into the third part of the stack, the third abstraction layer that I was talking about, hey Ton and Andy. Pre-configured images. So when I'm talking about pre-configured images, I mean an environment that already has ODL installed and configured, some artifact that we're shipping where that's true. As I talked about earlier, they're built using the configuration management layer, which in turn is consuming the packaging layer ideally. So we have nice separation of concerns and abstractions going on here. The 2 types of pre-configured images that we provide are VM images in the form of Vagrant base boxes and containers. And both of those are built with a tool called Packer, which we'll talk about super briefly right now. So Packer is basically a framework that you can plug in different types of build things into. So it could be like an Ansible role and a virtual machine, and then you come out with a virtual machine that's provisioned using the Ansible role. But any set of weird things you can plug together and build pipelines through it and get lots of artifacts out the other end. It's a really cool tool in that way. It's created by the same guys who made Vagrant, so it's a similar stack of tools, and they play really well together. And it has really nice docs, by the way. So this is a really old screenshot, but this is our Packer logic. Again, it lives in integration packaging, so you can go check it out there. Everything's in version control, so to your question again, it's totally automated. There's no additional logic that I have to like type in or something. It's just a one-off command that's well documented, and all the rest of it's automated in version control. A big win, as I hinted at with Packer, is that we're using Ansible for our configuration, and so we get really powerful knobs to change things, and we just have to solve the configuration challenges in the Ansible role, and then we get them for free in both our Vagrant basebox and container creation steps. So let's talk about containers a little bit. Again, they're built using Packer. They're available on Docker Hub. This is an old one, but that's okay. And again, we need an official account here. I think I didn't highlight that at the end, but everywhere we need official accounts. That's a to-do across the board. The container example is going to be really short because it's so simple. Our marketing folks, I guess Casey's in the room, should pay attention to this because I think it's sexy. This one-liner, this is our magic one-line crash shell. You can Docker run name of box and then the path to the carafe executable. And then all of this magic happens for you. If you don't have this image cast locally, it's pulled, the layers of it are pulled from Docker Hub, and then boom, we land in a craft shell. Magic, ta-da, yay. We can verify that our container is running with Docker PS, and of course it is. So super short example, that's kind of the point. We want to support other operating systems in our Packer build logic, and so right now we're just running against CentOS 7.2.15.11. I probably will hit Fedora next, and then the interns, part of the intern project is once they have a RPM, they're going to add the sort of rest of the stack behind that. And so, or sorry, once they have the dev package, they'll add the rest of the stack behind that, and if they have time. And one of the things they would add, probably the first thing they would add, is Packer build logic for creating containers and Vagrant base boxes based on Debian using that new .deb package. Both of these things can be reduced in size via some like strange optimizations around, for example, writing lots of zeros so that they can be compressed more efficiently and things. And I've got some Trello issues raised on the integration team's Trello board about specifics of how to do that, but I think we're going to end up with drastically smaller containers real soon. Moving on to the Vagrant base box. Excuse me. Same deal, built using Packer, configuration all available. Yet again, available via some nice, pretty user interface. So this one's called Atlas from HashiCorp. You can download it there or automatically. Overall, the Vagrant base box, I think, probably has the best user experience because people are familiar with VMs. It's already configured. OpenDaylight's there. It's a modern, updated image and everything. So for sort of new users or someone that just wants to poke a little bit at OpenDaylight, I would consider pointing them at this. Maybe we should add it to documentation places or something eventually. Let's see a quick example. It's going to be, again, really short because it's so easy. We're creating a Vagrant file in that first line, so Vagrant init, and then the -m just means minimal, don't add a ton of documentation to it, and then the name of the box, and so we're using the official OpenDaylight account, and then the name of the box is ODL. And we're just taking the latest tag, which is kind of implied, and that file was created in the first line, and we're catting it out in the second line. As you can see, it's incredibly simple. We can start our box with Vagrant up. That takes care of the download for us. In this case, it was a Lithium download. Our box is running. We can connect with Vagrant SSH, sanity check that OpenDaylight's service is running, and grab shells and poke around as we wish. In the future, we want other operating systems, as I've already talked about. We also have had a series of efforts around creating pre-configured tools VMs in the past. And so these are, for example, a dev will show up and be irritated that there's a hard spin-up process or something to get the right tools to contribute to integration and test. And so Lewis will create a binary blob of a VM that has some of these tools pre-configured and then share it via the wiki or something. And this is our historic way of solving that. We then moved to some Vagrant definitions to provide tools VMs that are at least not binary blobs and easier to distribute, and we can see what's going on. The sort of third phase of that, in my mind, is to create those tools VMs via Packer and ship pre-configured Vagrant base boxes that are ready for development for some particular project, some particular type of development. I think that'd be pretty sweet for spinning up devs, lowering overhead, making it easier to contribute to the community. Again, there's tricks we can do to reduce the size. So, in a few quick conclusions, and then I'll take any questions. We have a rich deployment toolset. We've kind of touched on all parts of the stack. We have options at different parts of the stack. The idea is that you should be able to sort of compose these together. You should be able to choose a set of them, apply them to your use case, and use them as building blocks. They enable modern OpenDaylight deployments, and so OPNFV, for example, can't just untar our tarball and then go manually set the right users and group permissions and then install Java and then start OpenDaylight, not via systemd and stuff. They have to have modern tools like this to do these massive automated deployments and stuff. And so this is trying to make that happen. Things like the Vagrant base box and the Vagrant OpenDaylight sandbox matrix of deployment options to OSs enable drive-by exploration and people to poke at it and learn about OpenDaylight. And we need to we're basically at the point now where we need to start consuming these things more. So our previous couple of releases, the RPMs have been getting more and more solid. We've been pulling them into OPNFV in more and more robust ways. We break things less. And it's the time now where we can start talking about them to people who we don't want to break things in front of. We can be fairly sure that we'll be all right in that space. Again, we'll probably start linking them from the downloads page and such. So let's start as a series of devs, as a group of devs, sort of promoting these, thinking about where we can use them, not duplicating efforts and stuff. I think that's it. Contributions welcome, of course. This is my contact info. There's probably know me or could find me otherwise, and I'll take any questions. And if there's no questions, I feel like we should just do introductions too.
This stuff actually ends up being used by integration tests.
To do the deploys of ODL. I thought about that. That would be super cool because it would be the most robust testing possible for this, and it would be a neat thing we could say to users or whatever, like, all of our system tests are run using this install method, so we're quite sure that it works and stuff.
No, but on the private cloud.
When we move into the private cloud, we should be able to actually utilize this because Node Pool gives us the ability to actually do our automated slave image build-up. And and since it also has the concept of a finalization readiness script, so we would be able to have it go in and do its finalization of, okay, now run this handful roll to finalize the system. Or this puppet roll, to, this is on, So,
we would be able to at least utilize most of those components because we wouldn't want to obviously install the final package using that necessarily because we still have to build it or it just was produced.
Right.
So we'd still have to get that part in there somehow.
Yeah, I think we could move in that direction in the ultimate, maybe termination phase, maybe. But I'll be real excited in Boron if we just get these things installing in CI and running regular tests against it. That's my objective for this release.
You mentioned earlier about getting documentation for this built up and potentially getting the Vagrant files available readily on the wiki. And I think that would be an extremely huge win for everybody.
Yeah.
And I think that we should set up a meeting, maybe even as early as next week sometime, to see if we can start to make that process happen.
Yeah, that'd be cool. We do have, all of these things have really solid docs, by the way. I took out a lot of slides to make this shorter and less formal, and some of them involve showing more docs and things. But there's a nice wiki, under our main wiki user space, just /deployment, that has an overview of everything here. That would be probably what we'd want to link to from user-facing docs. It's designed to be user-facing. Like, that's the abstraction that we've written it for. I think the first thing that we probably want to start letting users consume is the RPMs because they're so well tested. They're being consumed by OPNFV all the time. I'm very sure about them.
where is it being built?
The CentOS community build system.
Oh, so it's actually an EPEL or something like that?
It's not available via EPEL. I have to look into that. I don't actually know how to do that. But we have there's a .repo file available in integration packaging that we curl down.
Similar to Copper?
Yeah. It
Yeah.
ends up being similar, and you could probably get the RPMs into Copper quite easily.
We had them in Copper. We started in Copper, actually, and then we moved to the CBS because it's more official. I'm not sure if it's actually more official, but Copper has a weaker tool chain, basically. We can do more repos like this, and so we can have like a stable 4.0, for example, repo that will always have Open Daylight, Beryllium, not an SR, and then we can have like a 4 testing repo or something that allows us to do dailies, and you can choose which repo you're pulling from, and that kind of stuff wasn't available on Copper, I think.
Just an FYI, we do have the ability to host Yum repos out of Nexus.
Ooh,
Hydrogen actually has a Yum repo.
I've seen that. It's super hilarious. Anyway.
Yes. So, we have the tool chain to actually build locally and then host it. Just have to realize that there is no such thing as snapshots. There.
What do you mean by no such thing as snapshots?
Yum doesn't have snapshot capability.
What do you mean? I'm not following what you mean by.
In the Maven sense, there's no snapshot capability. So the Yum repo is a release repo. So
Oh, I see.
yeah, and you're running into this already, I'm sure, because everything you have in there is technically a release.
Yeah. Yeah, well, so we get around that. We basically do snapshots or like less official things by, there's the format is Open Daylight hyphen some number hyphen either, and then some sort of verbosity of releases statement. So it's release or testing or candidate are the ones we use. So we publish to testing very frequently and release very infrequently. And yeah.
That makes sense. But because we have the ability in Nexus to do this, that also gives you the ability to use our snapshot, or not our snapshot, but our staging repository components. So you'd be able to produce a staged one, and if it didn't pass testing, you just drop it.
Right. Yeah, that would be cool. I like this. I definitely want to get more integrated into our, I mean, right now, I actually probably should have included this in the slide somewhere, but we've, since early December, Ton has been producing dailies of auto-release builds, and I've been, not every time, but consuming those pretty frequently. It's super easy to do. We've got it to the point where you just add like 9 lines of YAML configuration and hit build, and you end up with an RPM. Most of that's copying and pasting, but it needs to be fully automated to really get it on a daily basis. And I've been thinking about how to do that, and it does seem very awkward with our current tool chain to work that into a totally automated system, because just passing of the information around and stuff is going to be a little bit wonky. And then I don't know how we would upload it from there to the CBS.
That's the problem, because obviously it wouldn't be in CBS.
So what I'm saying is that your solution here might be a really nice way to do sort of the daily aspects of this. So we could do automated daily builds, and then still have the CBS for, or maybe not. I was thinking having CBS for public consumption.
You might want to go that way, but if you take a look at a lot of the other projects out there that aren't officially part of CentOS or EPEL or anything else like that, say for instance Jenkins. Jenkins hosts its own Yum repository. They host their own apt repository. If you want this application, you install their connector essentially. So the Yum repo file.
The .repo file.
Yeah, the .repo file, and you're good to go then, because then you're in their repos.
Yeah, cool. Yeah, those are all good thoughts, good outcomes. Anything else?
Really like your slide deck.
Oh yeah?
Really good. Really looking at
Have you ever seen me do like a one I've really practiced a lot talk? Those are fun. I spit a lot more information, same style of like quick slides. I'm gonna do one at ONS, or not ONS, at ONS. Yeah, I'm really a defector going to ONS, guys. All right, well thanks. Artifact that comes out the other end of the pipeline, like a vagrant-based box or a Docker container, in the opposite order. And all of those are built with a tool called Packer, which we'll talk very briefly about. So cool, jumping into the packaging layer. Again, I think of this as handling system-level dependencies. So for OpenDaylight's case, that would be mostly installing Java, and then laying down the basic files in the file system. So just dropping things, our tarballs extracted artifacts in the right place, making sure they have the right permissions and such. Creating the users and groups to set the right permissions, of course. We also do configuration of systemd in our case, but in general, the thing that's going to manage OpenDaylight service via the packages. We currently support an RPM, or series of RPMs, which we'll talk about in a second. We have an intern. I have hired an intern through the Linux Foundation to start working on devs. Super exciting. I have tons of reasons why I'm excited about that. We'll come back to it. Anyway, but they'll start in May, I think, so it's going to be a few months more before, unfortunately, that work starts going on. They're already getting spun up. We're already communicating emails and things, so I'm pretty excited. Very talented intern, too. I think it's going to go well. Lithium, there's current ones for beryllium. And then once you have that file in the right place, it happens to land with the right permissions, which is quite nice. You can just sudo yum install -y OpenDaylight and downloads, and you're good. You can then start OpenDaylight systemd service with sudo system control start OpenDaylight and verify that it's running with is active, and it in fact is. So that's all fun. We can grab our shell and install any features that we want. So that's the end of the RPM example. A few quick to-dos. RPM-wise, we have started signing ODL's artifacts, or tarball release artifacts. We also need to start signing our RPMs. We've got a decent web of trust going on here, so I think it's time. We are not doing anything right now in CI for integration packaging, and that's going to be a trend across the whole stack. We need to start, if we could build RPMs in CI, that'd be great. If we could test RPMs in CI, that'd be great. We're currently able to test both the RPM and the package, the configuration management layer via Puppet, via OPNFV, because they're, all right, so the RPM, it's available under the integration packaging repository. Every screenshot here is old, by the way. This is sort of a deck that I forked and then changed and stuff, but I didn't update any of the screenshots because I didn't think you'd really care, but all the screenshots are like 6 months old. It's built and hosted on the CentOS community build system, so that's fairly official, I think, and robust and doesn't seem to break, and it has nice tool chains, and I've finally worked with the committers to get sort of the right build tags, and so we're all being consumed correctly. This is the web interface for the Koji CBS instance. Let's see a quick example of how to install from the RPM. This is the trend. I'll show how to install with each of these tools. It's kind of a teaching thing about them. So with RPMs, you have a repo configuration file that basically describes how to find our repository. So a .repo file. It just contains, the most important thing is the URL there that says, here's how you find the community build system, here's how you find Open Daylight's RPM. So there's an example of that .repo file. That's actually what the screenshot is of that we provide via integration packaging. You can curl down that example, and there are a bunch of other examples. This one's for. All right, so this is going to be kind of a laid back, but we do have slides, so it'll be not quite my normal sort of fast-paced, well-rehearsed talk that we see at ONS and stuff, but interject at any time, conversation's okay, we can take breaks, but we'll be using a slide deck. So this talk is going to be kind of a, where are we with integration packaging, some interjections about what we want to do in the future, and then I would love to, we have almost no one here, but if anyone has any ideas about the requirements that they want from us and other ways that we can improve our stack, that would be cool too. So a quick outline about what we're going to be talking about today. I like to think of basically what we serve in terms of a 3-layer stack. I think the abstractions are useful in that way. So I'll be describing them in that order. The first layer is the packaging layer, so that includes things like RPMs and debs. The second layer is a configuration management layer that consumes the packaging layer and then does additional configuration on top of that. So this would be like our Puppet module and our Ansible role. And then the third layer, top layer, is the pre-configured images layer. So those consume both the packages and the config management thing to create a sort of final, well-configured. That's how they consume Open Daylight. And so they're doing that every single day with their CI builds and running big complicated tests and such against it. So we have a lot of confidence that that part of the stack works at least. I talked about building the RPM in CI, or not really CI, but in Open Daylight's infrastructure. It's also time now to start directing users at the packages. In our downloads page, we've only linked to tarballs for a long time. We had a conversation about doing it for Beryllium, but it didn't happen. Maybe not the best reasoning about why, because they're not hosted on Nexus, which was the reasoning, and so it's not like an official artifact in some ways, but I think the community build system is a good official place to host it. So just more discussion would need to happen, and then for Boron at least, I think we'll start directing users there more publicly. That's it for RPMs, and I could talk about debs, I guess, but if anyone has questions about debs, we could talk about that later. Yes? Can you, first off, because it's mostly about the recording, but can you say that into the mic?
So my question is, so do we also have the source code RPM?